Welcome to another virtual lesson presented by the Opinionated Science Educator. Today's lesson focuses on experimental design. Now, I ended up facing a bit of a conundrum because this lesson was based on collaborative group work, and there's no collaborative group work in these virtual sessions. So what is a conundrum? Well, a conundrum is defined as a difficult and puzzling question to solve, one that some say is insoluble. Now, by insoluble, I don't mean it doesn't dissolve in water, but it's difficult to solve. So I faced a conundrum. How do I conduct this session on planning a scientific investigation without collaborative group work, or without being able to ask you particular questions to see if you know what the various things are, such as what variables will you control, what is your independent variable, what is your dependent variable, how will you plan out how you will collect your data. So yes, I faced a conundrum. For planning scientific investigations, I like students to collaborate and work in groups because I find it's a very important tool in helping develop your understanding. And that's something that I don't just think is true. I know it's true. It's based on research. Already way back in 1997, in the journal Cognitive Science, when discovery learning and inquiry-based learning were new in science education, a study was done. Now, the researcher from Japan basically compared students working in pairs with students working on their own, and he measured their success at coming up with hypotheses and developing scientific explanations. And the pairs did much better than the students who worked on their own. So that's why I think it's very important that planning scientific investigation activities be done as part of a collaboration. So without that collaboration, I had to rethink what I would be doing with you. That meant making sure that I knew exactly what my outcomes for this lesson were. So my outcomes for this lesson were for you to be able to ask a scientific question that is testable, that you then develop a hypothesis for that scientific question. You are able to identify the variables in the experiment and which variables need to be controlled, and that you can plan a step-by-step procedure that includes thinking of some of the potential risks and dangers. So what I've done is I've scoured through YouTube looking for videos that deal with planning scientific investigations. I'm going to be using those videos to make you think about certain questions that I want you to be able to do, such as, can you identify the variables? Is this question answerable? Do you think this is a step-by-step procedure? And hopefully by doing all of those things, you will still, at the end of this lesson, be able to set an investigative question that is testable with a proper hypothesis, where you've identified all the variables and you've created a step-by-step procedure that includes a risk assessment. So I hope you enjoy this lesson. All great scientific discoveries begin with somebody noticing something. Isaac Newton saw the apple fall from the apple tree in his orchard. Alexander Fleming, probably fuming that he'd allowed his bacteria cultures to get ruined, suddenly noticed that no bacteria grew where the mold was growing. So they observed. We need to start this lesson also with an observation. To do that, I've enlisted the help of Howcast and their YouTube channel.
I'm going to show you how we can make a boom in the room, and all I need are two household chemicals, baking soda and vinegar. Vinegar used in salads, baking soda to keep your refrigerator smelling good. And watch this. All I need is a paper towel and some tape, and I'm gonna make something really amazing. Baking soda. Now your measurements are key here, okay? You do not want a giant heaping teaspoon. I want one leveled teaspoon, and I'm going to put it right into the center of my towel. And that's one. And then I'm going to take a second teaspoon. And I'm going to take a third teaspoon. And I'm going to go one more and do teaspoon number 4. Now, I'm going to take this towel and I'm going to create like a package, like a little present. I'm going to fold and keep all the baking soda concentrated in the center, and I'm going to fold. And I'm going to flip it over, and I'm going to fold, and I'm going to fold, and now what I've created, piece of tape, was a way to control when I want the baking soda to be released. Now, step 2 is I get rid of my Ziploc bag, okay? And I'm going to take vinegar. It could be red vinegar, it could be white vinegar, it could be distilled vinegar, doesn't matter. Vinegar. Half a cup of vinegar. And I'm now going to take the vinegar, which is now the shape of the cup. It's a liquid. I'm going to pour it into this bag. And it's now the shape of the bag. Now I'm going to take my packet, but there's a problem. The minute or the second I release this packet into the vinegar, there's going to be a chemical reaction. The two chemicals will mix and something new is made. And I'm going to give you a little clue. You know what's being made? A gas. See, chemical reactions when something new is made, but the problem is, if I drop this into this, it's going to make a gas, and if the bag is open, where does the gas go? It's going to go up. But we're going to make this a little fun. I did say a boom in the room, and now I'm going to zip the bag shut. And if you notice, I'm holding this bag from the outside so that I didn't release the baking soda yet, because once these two chemicals touch, chemical reaction. And now I'm going to double check the bag, triple check the bag, and if it is going to go kaboom, I don't think you want to hold it here. I'm going to hold it over here, and I'm going to let it go. I'm going to press it so that the vinegar gets absorbed by the towel, and let's observe what happens. It's in. And right now the baking soda and the vinegar are going to start to mix, and oh whoa, dude, hello. Okay, this isn't funny. I'm scared. Woo! Sorry. The bag just farted. Did you see that? All that gas is being made, so much gas, it had to find a way out, created so much pressure, boom in the room. So, by doing that and mixing those two chemicals, we were able to make an amazing chemical reaction, make a super safe controlled mini explosion, and learn a lot about how gases are being made. Go try it, have fun.
That, grade 12s, is the introduction to session 13. I've explained to you why we can't do the activity as it's laid out in your study guide. And I've also tried to get you to think about the kinds of questions you should be asking. So, did you see that the pre-lesson activity sent you to look at video tutorials about different ways to measure the reaction rate? For this reaction, carbon dioxide is produced. So which of these methods would you use? And why would you use this method? Finally, what will your independent variable be? What will you measure? What variables will you need to control for? That is exactly what the rest of this lesson is all about.